we've looked at some of the sorts of planets that have been discovered around other stars and the possibility of searching for Earth-like planets. Let's just now review some of the missions that have been already implemented and are planned for the future to look for biosignatures in atmospheres of extrasolar planets. Well, first of all, it's worth noting again that the search for exoplanets is a research field that is rapidly accelerating. New planets are being discovered all the time, and the various methods that we've looked at for searching for exoplanets are revealing many of these new planets. The first analysis of an extrasolar planetary atmosphere was undertaken in 2001 by the Hubble Space Telescope, and it found sodium in the atmosphere of a hot Jupiter, the first time a definitive element had been identified in an extrasolar planetary atmosphere. The Hubble Space Telescope also identified other gases in 2007. It saw methane and carbon dioxide for the first time in an extrasolar planetary atmosphere. And in 2007, it detected water vapor in the atmosphere of an extrasolar planet, assisted by the Spitzer Space Telescope. The Spitzer Space Telescope has also been a remarkably successful mission. It was developed by NASA, the European Space Agency, and Caltech. It was launched in 2003, and one of its objectives has been to look for infrared spectra of exoplanets. It's found water and carbon dioxide in extrasolar planetary atmospheres, but it's also made other discoveries. For example, it's found atmospheres with dense cloud cover on other planets. And it's also found prebiotic molecules, potential molecules that could be involved in early building blocks of life in young star systems, such as acetylene and hydrogen cyanide, giving us new insight into the possible sources of early molecules that could be the building blocks for life in other star systems. Yet another mission that's been developed and launched is CORO. This was developed by the French Space Agency in collaboration with the European Space Agency and other organisations. It was launched in 2006. Now, this mission was not specifically looking for biosignatures in the atmospheres of extrasolar planets, but it has been remarkably successful in discovering new planets using the transit method. In fact, it discovered one of the smallest exoplanets that was known at the time it was launched, CORO 7b, which is about 1.6 times the size of the Earth. Since that planet was discovered, smaller Earth-like planets have been discovered. This has also been a very successful mission. Perhaps the most remarkably successful mission in recent years has been the Kepler Space Telescope, launched in 2009. And it does have a focus on small Earth-like planets. It's identified more than 50 planets residing near the habitable zone around other stars. In 2011, it found the first 2 Earth-sized exoplanets orbiting a star similar to our own. These planets, though, are probably too close to their sun to have life. They're just too hot. But they did demonstrate the first detection of rocky planets of similar size to the Earth, terrestrial-type planets that were the building blocks of new types of searches for Earth-like worlds. There are future missions that are planned. For example, the Gaia mission, which is being developed by the European Space Agency, is planned to be launched in 2013, and it will be capable of detecting tens of thousands of extrasolar planetary systems. The James Webb Space Telescope, developed by NASA in collaboration with other space agencies, is also going to provide a next generation of infrared analyses, allowing us to look at the atmospheres of extrasolar planets. And ECHO is a European Space Agency mission planned for somewhere around 2020 that is specifically focused on the characterization of atmospheres on planets within the habitable zones of their stars. There are also plans to develop sophisticated methods based on the surface of the Earth that would look for extrasolar planets, extremely large telescopes that will have the capacity to look at extrasolar planets and possibly to try and image them directly. There are 3 projects funded to date, and they may enable us to look for Earth-like planets looking directly at the light given off by those planets and so directly image them. So what have we learned? We've learned that the first analysis of an exoplanetary atmosphere was performed by the Hubble Space Telescope. We've learned that since then several exoplanet missions have been launched, the Spitzer Space Telescope, CORO and Kepler as examples. And we've already found prebiotic molecules in early star systems and begun to characterize the atmospheres of extrasolar planets. We're not yet at the position of being able to look for biosignatures, but we now know how to look for spectra of exoplanets. And since the launch of Kepler in 2009, the known number of planets in the habitable zone or near the habitable zone of distant stars is greater than 50. And several new initiatives for exoplanet research are scheduled in the next decade, with an increasing focus on life detection missions, eventually leading to telescopes that will allow us to search for the biosignatures of life in the atmospheres of extrasolar planets.